Okay, that's lovely, yes. Right, expensive request. Right. The length of a rectangle. Okay folks, welcome back. Question number 21. The length of a rectangle is 30 centimeters correct to two significant figures. Okay, that's just a very flash way of saying they measured it to the nearest centimeter. Okay, so you got your first significant figure and second significant figure, which is in units. 18 centimeters to two significant figures. That means to the nearest centimeter. First SF, second SF, which is in the units place value. So let's have a quick look at these questions. So as now 30. And the next centimeter after 30 is?
31.
And the centimeter before 30 is?
29.
And 18, and the next centimeter after 18 is?
19.
And the previous one is?
17.
Now it goes a bit down to the nearest centimeter. That means half a centimeter here and half a centimeter there.
29.5.
So that'll be 29.5, half a centimeter back, and half a centimeter forward will be?
30.5.
So this is also done to the nearest centimeter. So that's half a centimeter here and half a centimeter there. So that'll be 17.5 and
18.5.
5. So this one here is the width. And this one here is the length. Just write down the upper bound of the width. The upper bound of the width is 18.5. Okay, calculate the upper bound for the area of the rectangle. Okay, let's have Mr. Umar. How do we work out the area normally of a rectangle?
Is it length times y, width times y height?
No, that will be volume.
Oh, that's okay.
Okay, so area of the rectangle is just length times by width. Okay, Mr. Ramiz, we will need to work out the upper bound for the area. So if I want to make A upper, I want to find the biggest possible answer the area could be, I must start with the length upper and times it by the width upper. Okay, where is the length upper? The length upper is where? Here, the biggest length. Where is the width upper? There. So let's put these values in. The length upper is 30.5. The width upper is 18.5. And we put this into the calculator. And I'll do as well. So if you can have go on your calculator. Is 30.5 times by 18.5 equals, what do we get?
564.
22.5.
Okay, they haven't asked us for any particular degree of accuracy. 2 decimal places is lovely. That will do as our final answer. Done. Next question. Are we happy with that, folks? Happy? This is one of the topics we just done recently in our previous lessons, isn't it? Bounds. Number 22, the diagram shows a child's toy. I'm just going to move it up a bit. Okay, we have the toy is made from a cone, which is over here, a cone, like an ice cream cone, on top of a hemisphere. Hemisphere is like having a ball that's been cut in half, like a cheese ball, something which is solid. Okay, and you cut it in half. That's the bottom part over here. The cone and hemisphere each have radius of 7 centimeters. The total height of the toy is 22 centimeters. Now, if this is 7 here, what is the distance here? 7, because that's the radius there and the radius down there. So, that's 7 centimeters. What's this going to be then? It's 22 altogether. That's 7. So what's left over?
15.
How many?
15.
15, thank you. So that's going to be the height here then. So the height of the cone the question goes, work out the volume of the toy, give your answers correct to three significant figures. Okay, now, if we turn to the front of our paper, right, what is the volume of a cone? So to work out the volume of the shape, so volume of the toy is equal to the volume of the cone plus the volume of the
Sphere.
hemisphere. Hemisphere means half a sphere. Okay? Now, the volume of a cone, the formula for it is force, okay?
1/3 pi r squared h.
1/3 pi r squared h. And the volume of a hemisphere, okay, let's have Mr. Hamza. Mr. Hamza, give me the volume of a hemisphere.
Divide by 2.
You have to divide by what's it start with? Look at the front sheet. Look at the front sheet.
4/3.
Okay. Go on then. Okay, so the formula for a sphere is 4/3 time by pi time by r cubed, is that right? And then we have to divide it by
2.
2. Why do you divide it by 2? Because it's not a full ball, it's a half a ball.
Yep.
Now you need to put the values in there. Okay. So we got 1/3 time by 3.14 for the pi value. The radius is 7 squared time by the height. What's the height of the what of the 15? I'm going to do this part over here at the bottom. Add. So we got 4/3 time by 3.14 time by the radius cubed, which is what is it?
7 cubed.
7 cubed, and then we can put a divide by 2 here actually, and that will work just as good. So that calculation, that string calculation, we need to pop it into fraction button. 1 replay 3 time by 3.14 time by 7 squared time by 15, and then we have to add on to that fraction button. We have 4 replay 3 time that by 3.14 time that by 7 out of 3. Hang on 1 second, folks. Done a bit there. 15. Add fraction 4 replay 3 replay time by 3.14 time by 7 cubed, and then divided by 3. Okay, what do we get, folks? What kind of answer are we getting at the moment?
1,409.
Okay, I'm going to change the color. Do we get 1,487.31? Okay, now. Okay. In this particular question here, folks, it goes give your answer correct to 3 significant figures. Okay, 3 SF. Okay, that's my calculator display part of it. So first, second, third. That's the last digit, that's the decider. Because it's 5 or more, what do we do to 8? Add 1. So 148 becomes 1490. So it becomes 149, and then we have a gap between the 9 and the decimal point, so that gets filled with a 0. So ignore this part here, that's just my answer there. That's not equal to this, by the way. What is it? Actually it is. Okay, 1490 is the volume in centimeters cubed. Okay, what's the next question, folks? Let's have a look. Okay, Mr. Ramesh, how are you doing on that? You doing good?
Yeah, fine.
Okay, put your hands up if you got that one right for homework. This question. 1, 2. Okay, 2 people got it right for homework. Okay. Okay. going to have to do a table and then we're going to have to do, I have to use somebody's exam paper because I can't do both at the same time. I can't do the table and that at the same time. We'll have to do the table first and then rub it off and then bring the graph up, okay? Right, the next question. The table shows information about the total times that 35 students spent using their mobile phones 1 week. Okay, 35 students, I mean I'm sure the data is wrong. There should be one that says here more than 5,000 hours, or 35 of them. Yeah, students are always on the phones. Okay, now we've got 0 to half an hour, we've got 8 people, half an hour to 1 hour is 7 people, between 1 hour and less than 2 hours is 11 people, greater than or equal to 2 hours but less than 4 hours is 9 people. Okay, on the grid below, draw a histogram. Now in your histogram, what's the key word in the histogram there? It says frequency, density. Okay, we say that the frequency density is equal to the frequency divided by the class width. Yeah? This is my class here. The class width is not the width of this class here. It's the width of the class of data from here to here. So let's put here CW. Okay, CW. Now, how wide is between 0 and half? How wide is that? Half. How wide is from half to 1? Between 1 and 2?
1.
Between 2 and 4?
2.
2. That's frequency. Put another column here. Frequency density. Now, if I want to work out the frequency density, I've got to get the frequency divided by the class width. So I've got to get this number here and divide it by that one, yeah? Mr. Ramesh, are you with us? So 8 divided by a half. 8 divided by half, please don't say, I don't even say 4. If you say 4, I'm going to jump out the window.
16.
16 is better. Okay, if you have 8 cakes and you divide them into halves, how many pieces do you get? 16 pieces. Okay? 8 divided by half, I know it might sound like in your head like 8 divided by 2, but it's not 8 divided by 2, is it? Okay, so, right, 8 divided by a half, we say is equal to 16. Next, 7 divided by a half.
14.
We've got 11 divided by 1. That's a really hard question, folks. Don't rush it all.
11.
11 divided by 1. You sure? You want to change your mind? Okay. Next we have 9 divided by
2. 4.5.
Okay, lovely. Right, has everybody got that table nicely properly done? Because I'm going to need to borrow some of these exam papers so I can do the next part question. I need to rub this off now, folks, because I need to bring the graph up. Okay, that's lovely. Right, did you copy it properly from the board? Yeah? The numbers. Okay, now actually you have to draw yours. Who's actually drawn it? That's right. Okay, what does the frequency density go up to? What's the maximum? What's the maximum? 16. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's it. No, we don't know what to go in ones. 16, 12, 10, 8, 6. I'm done. I've done something crazy, folks. Okay, I think we should start with the bottom. That might help. 0, 2, 4. Kind of backwards, kind of wrong. 0, 2, 4, 6, 8, 10, 12, 14. Okay, 16. I think that's much better, isn't it, Ishan? I think I was doing a bit of a doodle there. Okay, right. Okay, we've got our frequency now. Let's have a look what we've got for our values. So we have here from 0 to a half. 0 to a half is, that's my first width, 0 to a half. And the height is, okay, at the moment, folks, I'm doing freehand. Can you please make sure that in the examination you do with a ruler? I'm doing it nice and quickly freehand. Okay, then it goes half to 1. Half to 1 is here. And that has a height of 14. Folks, don't forget you should be using a ruler, or you should have already done this question. It looks like most of you are doing it right now. You didn't do it for homework. The next one is 11, which is between 1 and 2. Between 1 and 2 is 11. And the next one between 2 and 4. 2 and 4, that one has a height of 4.5. Okay, you don't need to shade them in, but that one's done. Who's this?
Mine.
Can you pass it back, please? Okay, question number 24, 25, 26. This one gets bit interesting. We will try to finish question 24 now, inshallah, before we go for our home time. And question number 25 and 26 are left. Inshallah, I'll do them later on tonight. We'll get them done for you for the video. Okay? Alright? I'm sure most of you have done that anyway, you got it right.
So you might as well wait and let the video start again.
Yeah, is it going to be running out?
Yeah, it's in about a minute.
Okay, let's stop that video then. And start again.